All right, so today we're going to work on lesson 6.2, solving multi-step inequalities. So we're staying with the inequalities concept. We're going to move into solving inequalities that take a few steps rather than just a simple one-step uh, process. It's the same solving process really that we worked on yesterday. That's the same concept as how we solve equations. We're working to isolate a variable, get a variable by itself on one side, and we want it on the left because the best way to solve and understand inequalities is to be able to read them left to right. All right, so our first step in this process is always the same. We're going to simplify each side of the inequality sign. So we're going to distribute, we're going to combine like terms. We can do whatever we can to write each side with as few terms as possible. After we do that, then we need to isolate the variable term. Now, if we have variables on both sides of the inequality, then here's where we're going to eliminate one of them by adding or subtracting it to eliminate it from one side, thus giving us a variable term on only one side. After we've done that, then it's about trying to make the coefficient of that variable term become a positive one, and we do that by multiplying or dividing to create that one. And then here's where that one little step is. If we multiply or divide using a negative number, then we got to switch that inequality sign. All right. So a little repetition with this, and I think we'll have it. First things first, let's talk about solutions to linear or multi-step inequalities. Again, with inequalities, you can have a infinite number of possible solutions because we're trying to find all the values of u that make this true. With an equation, there's one answer generally. With an inequality, there's an infinite number of solutions. So that's what they're getting us to look at here. Look at of these choices, how many, if any of them, make this true? Well, what we'll do is go ahead and plug it in. So we'll plug in -10 for u and then do the math, and we get -72 is greater than or equal to 19. Now we're just answering that question. Is that a yes or a no? The answer is no. -72 is not greater than greater than or equal to 19. And then we start to check the next one. 7 times 9 minus 2 greater than or equal to 19. 63 minus 2 is 61 greater than or equal to 19. Yes. How about 3? Okay, well, that would give us 21 minus 2. 19 greater than or equal to 19. That is true. Correct. 19 is equal to 19, and greater than or equal to means it can be greater than or equal to. So we're good there. And then our last one, -6, we get -44 is greater than or equal to 19, and we know that is false. Okay, so here we're just looking at how we can substitute in values and check their validity of whether they work or not, and understand that there are an unlimited number of possible answers to this problem. Okay. Now, getting into the process of solving multi-step linear equalities, it's the same as equations like we've talked in the past. Um, when I go to solve these, the first thing I'm going to do is switch sides. I want my variable on the left. You always want to read an inequality left to right. Variable compared to the number. All right, so the first thing I do, now when I switch sides, I switch inequality. This statement and this statement are equivalent. They mean the same thing. And now I go to work trying to isolate my 3y. Well, that means I want to make this 15 a 0, so I'm going to add 15 to both sides. Okay, this is now a 0, so I got 3y less than 24. Now I want to make that 3 become a 1. I want to know what 1y is compared to, so divide each side by 3, and y is less than 8. So what we're saying is you can put any number in place of y, and it'll make it true as long as that number is less than 8. So you get an infinite number of possible answers. Okay? All right, let's look at the next one. So I got another inequality. It's multiple steps. It's going to take a couple steps to finish here. But the first thing I want to do is get the variable on the left. So I'm going to switch sides and switch the inequality. Okay, now I'm going to go to work on getting 4x isolated. So I want to get this 6 to become a 0. So I'll subtract the 6. So I'll get 4x is less than or equal to -12. Now I want a coefficient of my x to be a 1, so I'm going to divide each side by 4, and I get x is less than or equal to -3. So again, what we're saying is as long as you put a number less than or equal to -3 in this place, this will always be true. Okay, another one here. Now our variable term's on the left, so I don't have that first step of switching sides. Now it's just about solving. So first things first, is my equation simplified? Yes. All right, well, then let's get the variable term isolated then. I want to get negative 4w over here by itself, so I'm going to add 1. Negative 4w greater than or equal to 20. Now I want the w to have a coefficient of 1. It's negative 4 right now. I want it to be 1. So I got to divide each side by negative 4. Here a little alert should go off to you. If we ever divide or multiply by a negative number on each side of the inequality, I got to switch that sign. So now I'm switching my sign and then do the simplifying. And I get w is less than or equal to negative 5. Okay. Another one, this one has a fraction in it. Still can do the same solving process. If I look at my inequality, I got 2 terms on the left, 1 term on the right. This is the variable term, so I want to isolate it. So the first thing I need to do is to eliminate this minus 19, which is really like a negative 19. So I'm going to add 19 to both sides. Negative 19, positive 19, that's a 0. And then negative 9 plus positive 19 is 10. So I got negative 5/3 x is less than 10. Okay, the coefficient of x is negative 5/3. I want that to become a positive 1. So what we're going to do to make it a positive 1 is multiply both sides by the reciprocal, which is negative 3/5. I want it to be the same sign because negative times negative is positive. I want it to be a reciprocal so I can cancel the numerators and denominators. And then I got to do the same thing on the other side, multiply by negative 3/5. Whatever I do to the left, I got to do to the right. And because I'm multiplying using a negative number, the inequality switches. Notice it's less than, now it's greater than. All right. Now this is going to cancel to give me positive 1. Over here, you guys can do this. 5 goes into 5 once, 5 goes into 10 twice. I'm left with negative 3 times 2. X is greater than negative 6. Okay, just got to be careful on that last step there. Okay, this involves a little bit more. Okay, and this goes to the first step that I gave you for solving these. The first thing we need to do is simplify each side. So the left side is 5u minus 33. That's just 2 terms, and they're not like terms, so I can't do anything about that. Over here, I got negative 2 times a quantity, 4 minus 5u. That means I can distribute over here to make this a little simpler, so I'll do that. Negative 2 times 4 is negative 8. Negative 2 times negative 5u is positive 10u, excuse me. All right, now I got variable terms on each side of the inequality. We don't want that. We want just a variable term on one side or the other. So I'm just going to work to get the variable on the left. So I'm going to eliminate this 10u by subtracting 10u. Then I got to subtract 10u from this side. All right, so 5u minus 10u, that's going to give me negative 5u. Still got the minus 33 greater than negative 8. Okay, now we want to isolate our negative 5u, so I want to get this negative 33 to become a 0, so I'll add 33 to both sides. Negative 33, positive 33, 0. Negative 8 plus 33, 25. So my negative 5u, I got a coefficient of negative 5. I want that to be a positive 1. So I'm going to divide each side by negative 5. Alert yourself here. We're dividing using a negative number. So that means I got to switch inequality. Notice I've already done it. It was greater than, now it's less than, because I divided by that negative. And then simplify what's left, and you got x is less than negative 5. Okay? Pretty straightforward. Just equation solving with that added little extra. Now, threw one of these in here. If you remember, what we did is when we got an equation before that had fractions in it, we could multiply to eliminate all the fractions and then make the problem a little easier for us to work with. Well, we can do the same thing with equalities. All right, so what we're going to do is I want to find the smallest number that 6 and 8 will go into evenly. All right, and then I'm going to multiply everything by that number. It's called the least common multiple. I'm going to multiply all the terms, the 2 terms on the left, the 2 terms on the right. Everything gets multiplied by that number. That keeps the inequality equivalent to what it is originally. And then I can solve from there. So I'm going to multiply both sides by 24. Okay, now distribute that 24 through. 24 times negative 7/6. So what I'm thinking is 6 goes into 24 4 times. And then 4 times negative 7 will be a negative 28y. And then 24 times negative 1 is negative 24. Over here, 24 times 3/8, the 8 goes into 24 3 times. 3 times 3 is 9y. Again, 24 times 5/6, well, the 6 goes into 24 4 times the 5 is 20. So when I distribute the 24 through, I will eliminate all the denominators. Therefore, I just have whole numbers that I get to work with. Okay, nice simple step. Okay, the next step in the process is I got a y term on the left, a y term on the right. I only want one y term. So I got to make one of them a zero. I'm going to subtract 9y from both sides. So my variable is on the left. So negative 28 minus 9y is really negative 28 plus negative 9y. That's negative 37y. Minus 24 is greater than 20. Remember, that's a zero. So we got a 20 over here. Now we want to isolate our variable term. So I want to make negative 24 become zero. So I'll add 24. Negative 37y is greater than 44. Divide each side by negative 37 because I want to make the coefficient here a positive 1. Because we're dividing by a negative, we got to switch the sign. Solution, y is less than negative 44 over 37. That's how I leave it. Okay, don't write it as a decimal, then you got to round it or something. Just leave it like that. Okay. Last thing, talking about when we get no solution or all real numbers as a possible answer to an inequality. This is all about you go through the solving process, and if our variable term cancels out on both sides, so we're just left with a number greater than, less than, another number, it's about, is that true or is that false? Okay. And that's what makes our determination. If the remaining statement is false, then there's no solution. If the remaining statement is true, then that means it's all real numbers. Let me show you what I mean here. So it says, take this inequality and determine if there's no solution, if W is less than a number, W is greater than a number, or if it's all real solutions. So I'm going to distribute my 3 through this first parenthesis. Okay. And now I want to solve what remains. So just like we did, I'm going to subtract a 16W. Okay. I'm going to subtract the 24. I'm going to divide each side by 2. So W is greater than negative 2. So we got a W greater than deal, and it's greater than negative 2. That's my answer. Okay. If it was going to be the no solution or the all real numbers, then what would have happened here is I'd have had the same variable term on both sides. And then when I would have subtracted my 16W, this would have became 0. And then I would deal with what's left over, and we'll see what happens here. Okay. Same deal. Take the negative 5, distribute it through. I get negative 5y minus 15 plus 31. Distribute the 5 through here. I get 20 minus 5y. Simplify the left side. Negative 15 plus 31 is 16. Now I got a variable term on each side of the inequality. So I'm going to eliminate this one by adding 5y. And hopefully you see this negative 5y plus 5y is 0. This negative 5y plus 5y is 0. So what's happening is my variable terms have canceled out. Now it's all about this statement. Is 16 less than or equal to 20? True or false? That's true. 16 is less than or equal to 20. That means this thing, this inequality, it doesn't matter what you put in place of y. This is always going to be true. So y can be any real number. There is no limited here. It's an infinite group of solutions. It can be any number you want. It'll make it true. All right. So those are the types of questions you're working on tonight. Okay. Hopefully you jot a few notes down. The process of solving should be a review. Okay. So make sure you take your time with that. Do a good job. All right. All right. I'll talk to you later.